Not the ones that are the little shiny things on the dresses. Okay? Sorry. Just never mind. Okay. Yes, exactly. Okay, all right. Thank you very much. I appreciate that. Okay? I try.
She didn't
Little
laugh,
prom humor.
so it wasn't that funny.
Nice. Nice. Okay?
Well, she didn't laugh.
Okay,
You
okay.
didn't laugh.
All right, remember this whole conversation about talking to, people, the normal people? Never mind.
They're
Okay,
normal.
so
Kinda.
I want to focus our attention on a particular type of sequence called arithmetic. Arithmetic means that it has a constant difference between terms. When we use the word difference, what do you think? Subtraction. Okay, that's what we're going to do to find it. But keep in mind that arithmetic means you are adding the same number every time. Adding same number every time. Not adding same hashtag. Adding same number every time. So this one is pretty easy for you to tell what we're adding every time, isn't it? What is the common difference between every one of the terms? We will use the letter D to represent the common difference. What are we adding every time? We are adding a 1. Now, if you could not tell that easily, now I'm not saying for this one, I'm saying for something else, something more difficult, then you do that by taking any term and subtracting the 1 before it. So if you're trying to figure out what the common difference is, you could take any term and subtract the 1 before it. And you might want to do a couple of them just to figure out what the number is. Okay? Well, I should say the second one that you would do would be to verify that the first one was correct. That's the review for the test. Right. So we will eventually. You're right. Yeah, thank you for bringing that to my attention. Okay, so is this arithmetic? It sure is. Yes. The common difference is 1. That wasn't too bad a question, was it? What if if they're all like that, whoa, that'd be awesome. Okay. What if it was 2, 3, 4, 7? 2, 3, 4, 7. Is there a common difference there? It looks like it at the first, but then when we get between 4 and 7, we have a problem. So that would be a no right there, okay? But that's, I just made that problem up. That's not obviously part of this question. I'm just trying to illustrate that we could have one that does not have a common difference. Now, would I try to trick you? Probably not, okay? I'm not going to make the first 3 terms, work out nice, and the last one, that would be a touch on the evil side. Okay. What do you think about question 2? Is there a common difference between the terms? Are we adding the same number every time? Remember, when you say that you're adding the same number, it doesn't have to be positive. Are we adding the same number every time? Okay, you figure it out right now. Write down on paper what you think we're doing here. Okay. Are we adding the same number? Question 2. Figure out if we are adding the same number every time. Remember, you can always take any term and subtract the previous one and see what that number is. Do it twice, and you'll know for sure. Yes. any term, so pick like -13 minus -10. So let's start out by writing that. -13 minus -10. And then I would do -16 minus -13. If those numbers end up being the same thing, then I know the answer is yes. So what is -13 minus -10? Any term minus the previous one. -3. Okay, and just to double check, I'm going to do it again. Any term minus the previous one. If we get the same number, we know the answer is yes. And so the common difference is -3. I'm going to show you two different ways to do question 1. What if you're told that it's an arithmetic sequence, but there's a missing number in between? I'll show you two different ways, and then you make the decision on which way you want to do it. How many times am I adding this D to get from the first term to the third term? How many times am I adding the D? Twice, right? So if you take the first term and you add 2 D's, you end up with the third term. So we could actually set up a little equation like this. First term plus 2 D's gives me the third term. See if you can figure out what the middle term is now that you have that equation. But we can use that number to find the middle term. Okay? Because that's the deal. So if you start with 2, you add one of those D's. Good. You get the common difference is that, right? But I didn't use that in order to find the middle term. Okay, so we got the common difference is that. Good. Now how do I use that to find the one in the middle? What do you get? I'm kidding. Yeah, so start with 2, and what do you think D is? Tell me what that middle term is. Yeah, that's it. Okay, so several of you are finding that your D value is 12, right? Okay, do not write 12 on the line. All right, several of you are doing that. You're subtracting 2, you got the 24 equals 2D divided by 2, you got 12, right? That's awesome. That means every time you go to the next term, you have to add 12. So if I'm looking for the one in the middle, it's 14, right? Because I had to take the 2 and add the 12. So I got a term of 14. I almost hesitate to show you this next thing, but I am going to show it to you anyway, because I like you being able to think through the process of finding the common difference. But what do you get if you add 2 and 26 together and divide by 2? Now, what do we call that when you add two numbers together and divide by 2? Don't we call that the average? And what do you get? You get 14. Oh, look, the middle term. This, folks, is actually called the arithmetic average. Now, as you were growing up, we never said arithmetic average. We just said average. Or sometimes we used the term, also we used arithmetic mean. That is definitely a mean term. Thank you. Not my best work. So can you do it either way? Yeah, you can.
Why do you use
Because it's a whole lot easier.
I thought it was
I kind of like you understanding the process of how you find the common difference, though. The one thing you don't get from the one in the red, you don't get the common difference. Now, could you take 14 minus 2 and get 12? Sure you could. So we could still find a common difference. Yes? What are you making fun of me for? You were. You were making fun of me. I know you were. Yep. Mm-hmm. Okay. Now, I could. Can you tell me what the fourth term is? Yeah, you don't need that earbud in. Come on. This ain't time for you to work on your own or a test where you can listen to music on your buddy, that kind of thing. Sounds like disrespect to me. Unless you're getting information from your bookie or stock market tips or something. But it's not even open. 9:30 when it opens. Unless you do early hour trading. You have to pay money for that. So I don't think you're doing that. So let's see. Can you tell me what the next term is? The fourth 28. One? 28, right? How about the one after that? 35, 42, right? 49. If you're into football, maybe this is easy for you. Like 56, 63, 70, that kind of stuff. How many of you want to keep doing that until you get to the 110th term? I hope none of you. Okay? In fact, if you're going to sit there at your desk and go, plus 7, plus 7, plus 7, plus 7, I'll come over and stand by your desk while you're taking the test and shout random numbers into you so that, you're like, 3rd, 4th, 5th, 6th, 7th, 8th, and then you'll lose count and have to start over. Right. Because I don't want you doing that.
Wow.
Okay? That is actually called a recursive pattern. And sometimes that's the only thing we can do. But that's not true for this. Now, if you think about this just a little bit, first term, second term, third term, if you were to convert that into a formula, well, let's just take a look at what Desmos would say. Well, I just want you to see something and see if it makes any sense to you. So, the first term is 7. Okay? And the second term is 14. And the third term is 21. Now, what kind of pattern are you seeing? What kind of pattern are you seeing? What kind of pattern is it? It is rising, that's true. It's got a positive. It's going up by 7 each time. What kind of shape does that look like? Linear. This is based on a linear function, right? And what's the slope? You said it. How much is it going up? It looks like it's going over 1. So up how much over 1? Up how much over 1? Up 7 over 1. So what's the slope? 7. Oh, that's the common difference between the terms. Yes, that's true. The slope and the common difference kind of go together. So this is very predictable. We can find the 110th term. We just need a formula to get there. Okay? So let me show you how to do that. We call these explicit formulas. Now, why do they call it an explicit formula? Okay. I'm sure there's lots of inappropriate jokes for that, but we'll try to keep those somewhere else. The reason we call it explicit is because I can go to the 500th term by plugging in 500. I don't have to sit there with my calculator, plus 7, plus 7, plus 7, plus 7, plus 7. Okay, nobody wants to do that. We want to go straight to a particular term of the sequence. So an explicit formula looks like this. A sub n equals A sub 1 plus D times n minus 1. And I will walk you through all the parts here. This is a linear function. In fact, you've already seen this linear function before. It looked more like this. That really looks like the point-slope form of a line. So this isn't anything different or new to you. It just looks different. So for this particular formula, we need to know two things. We need to know the common difference. The first term. We need to know the common difference. And we need to know the number of the term that we're looking for. Okay? So the first term was a 7. The common difference is also 7. You guys told me that, right? D equals 7. It's positive because we're going up. That's the actual formula for this particular group of numbers. Now, they want to know the 110th term, so what do you think we're plugging in for n? What do you think we're going to plug in for n right there? 110. So take your calculator. Now, if you're good enough to subtract 1 from 110, you can type 109 in there, right? But if you don't want to mess with it, you can type it exactly the way you see it. Find me the value of that number. And tell me what you get. Did you get that? Okay. Now. Okay, I got you. Okay. Now, I have seen this happen many times. Many times. So if you did this, you are not alone. 7 plus 7? Illegal in every country of the world, folks. In the universe. People die over that kind of thing. Alright? Why? Because the order of operations says parentheses first, right? After parentheses comes what? Exponents, but I don't worry about that, right? After exponents comes multiplication. After multiplication comes addition. Now, if you type it exactly the way you see it right here, your scientific or graphing calculator knows the order of operations and will do it for you. It's when we start manually thinking things that aren't true that we start telling the calculator to do something wrong. Like 14 times 109. That'll give you the wrong answer. Okay? So, did you get something just under 800? 770? That's exactly what you should have gotten. 770. So, my advice would be just let the calculator do the walking on that one. Okay? Okay, question 5. A sub n. We need the first term. We need the common difference. So what's your first term? What goes in the first blank? What's your first term? 6. What's the common difference between the terms? Well, I don't know. Take any term minus the previous term. Some of you are already telling me that it's 6, and you would be correct. So that common difference... Now, don't think that every one of these questions are going to have the same first term and the same common difference. Okay, that just doesn't happen. It did in these particular 2 situations. That's kind of unfortunate, actually, because a little bit misleading. So we want the 70th term. Please tell me that's not it, is it? Oh, man. Oh, my goodness.
Yeah.
Gee whiz, this is like the worst question ever.
I love it.
We got you got middle school in here, and then the answers in middle school format too. Seriously. All right, so
Did you know? This is so random. Did you know Hitler's birthday is
yes. We got all kinds of cool things. I mean, there's National Joint Variation Days on that day for Algebra 2. Yeah, so it's the second largest holiday in Algebra 2 history. Right behind Pi Day. You got Pi Day, right? That's the number 1 Algebra 2 holiday, and then after it comes National Joint Variation Day.
Are we gonna have a party?
A Pi Day party? In a roundabout kind of way. Never mind.
Wait, we will be at school.
What?
We will. It's the 14th. It's next Thursday.
Oh my! What?
Party time.
13th is Friday, so how's 14th a Thursday?
I'm just kidding. I thought it was Friday the 15th.
Okay.
Just kidding. Never mind. Forget about
Yeah, I know
it.
somebody's getting married on Pi Day. Not for that reason. I think it was completely accidental. I thought it was kind of cool because I was like, "Ooh, that'd be easy to remember."
Brandon, you want to
Yep.
have a party on Pi Day?
Okay. Question 6. Find the missing term. Go. Find the missing term. Pick your favorite way you want to do it. Whether you do it the equation way or the arithmetic average way to find the middle term. No.
Dude.
Okay. It's very catchy. But I don't even remember a lot of them. Okay. Now the only reason that is true is because it started because those 2 numbers matched. The first term and the common difference matched. If they didn't, then that trick would work. So you're done? No. So this would be a 2D. 4 plus 2D. You're only adding D twice. Okay.
Okay, so
You do it either way.
numbers are just
You do it either way, but yeah, the average is a faster way to do it.
and then divide it by 2.
So that'd be 4 plus 2D. You're only adding the D twice. If you are using the equation. So far I've seen 2 people do this. How many times are you adding D? It's only 2 times that you're adding D, and some of you are putting 4 plus 4D, but you're only adding D twice. So if you're going to do it the equation way, that's one way to handle it. If you did it the average way, what'd you get? 18 is correct, right? 36 over 2. And obviously, if you did it the other way, you'd find out that 2D was 28. Wow, that's a weird-looking D. And then D was 14, and if you added the 14 to that, you would get 18. So either way works fine.
I don't think I can do like the equation.
Okay. Then you got the other way to go with.
Yeah.
Okay. And then if I ask you for the common difference, you would take the 18 and subtract the 4 and get the 14. Okay, so question 7. What question? Do we need something? You're all right? Okay, question 7. A theater has 44 seats in the first row. Okay? 46 in the second row, 48 in the third row, and so on. How many seats are in row 20? Yes, I will be looking for a formula for you on this. Now, 20 isn't too bad as far as, how far the terms go out. But you better show me the right formula to get the credit. So, what's the common difference? It's positive 2. That better go in your formula right about there. What's the first term? 44. And so we're looking for the 20th term. Your answer should be less than 100. Will you do that? Yes. That's it. I just wanted the 20th row. That's all. Yep. You got 82. Nice job. I believe so, yes. Yeah. Now, eventually this question is going to change. This question in the future, in a different section that we're going to get to later. Now, we're going to do a test over sections 1 through 3, but when we get to the second test, we're going to change this question. No, we're not going to say what is the number in the 20th row. We're going to say how many seats are in all 20 rows together. We're going to have a different formula for that scenario. So we'll come back to a situation like that. Okay, look at question 8 here. They want me to find the 17th term of the sequence. All right, so what they have shown me, so we've got the 17th term here. Can you tell me what the 18th term is? The 18th term is -4. All right, that's your 18th term. Stay with me. Don't look at the light. Now, and don't talk over me. Listen to me as I finish this question. To go from any term to the next term, you add the common difference. So to go from the one they want me to answer to -4, we have to add -11. So something plus -11 equals -4. How do you figure that out? If you add -11 to move forward, what do you do to go backwards? Subtract -11, but we really call subtracting -11 adding +11. If I add +11 to that, -4 plus 11 would be +7. So the missing term was 7. See you later. We'll finish that up tomorrow.